Okay, so now we're going to get into our first example. I'm only going to do this for the first problem. For the first problem, I want to remind you that we are verifying an identity. So in this first problem, when they say verify this identity, I want to remind you that what it means is that if we would graph it, the left side and the right side, I screwed that up. I got to fix this. The left side and the right side would be on top of each other. So I want to show you that I want to show you the graph of y equals sine squared x. And I want to show you the graph of y equals, the numerator is secant squared x. And they use theta. I'm switching theta to x. Minus 1 all over secant squared x. And again, I want to show you that they're on top of each other. I want you to see right there in my graph that my left side of the equation and the right side of the equation are on top of each other. And because every output is the same, this is no longer an equation. We're calling this an identity. It's an identity because the left side of the equal sign and the right side of the equal sign are on top of each other. So I'm going to take a screenshot of this, and I'm going to attempt to drop this screenshot in my notes here, because I want you to understand that these two graphs are identities, and they are always on top of each other. So this is the only problem I'm going to do this for. So in the future, I'm not going to graph them. But I want you to understand, when they say verify the identity, they're telling you that if you graph the left side and the right side, they're going to be on top of each other. So this is the only time I'm doing that. All right. Why did Mr. Lehman say that why did I say that this is my favorite section? I know that this is my favorite section to do this work because this is the more complicated side. This is the simpler side. And so I will be done when my last line says sine squared theta equals sine squared theta. So this is my favorite lesson because I already know the final answer. The final answer is sine squared theta equals sine squared theta. The issue is, and this is the challenging part, and this is also, again, I'm messed up. I'm a mathematical guy. I like this challenge. The challenge is I don't know the steps to get there. Those are supposed to be question marks. I don't know the steps to get there. But I know that there is a path that will get me sine squared theta equals sine squared theta. And the good news is that I've got 5 guidelines to help me get there. And the 5 guidelines are, hey, let's work with one side of the equation at a time, probably the more complicated side. Let's look for opportunities to factor. Let's look for opportunities to use fundamental trig identities. Let's use when nothing else works, let's convert everything to sines and cosines. And it's always important to try something. So I'm going to demonstrate trying something. Sometimes, and you've never really done this before, sometimes you try something and it won't work. So I'm going to try something. That's factorable. That's secant theta plus 1 times secant theta minus 1. That's factorable. All over secant squared theta. I factored. I tried something. I saw an opportunity to factor, so I factored. That is, I did not, everything's correct. And now, again, and that's just the left side of the identity. I have not touched the right side of the identity. The right side of the identity is still equals sine squared theta. I tried something. Now, step 5 says always try something. Step 5 says always making an attempt that leads to a dead end provides insight. So I tried something, I factored it, I know what my final answer needs to be. I need to figure out some more work because I need to get sine squared theta equals sine squared theta. And currently I don't have sine squared theta equals sine squared theta. Currently I have secant theta plus 1 times secant theta minus 1 equals secant squared theta. I tried something. I'm stuck. I don't know what I should do. So I tried factoring that and I'm stuck. I don't know what to do. So, congratulations. You've experienced your first attempt of trying something and it not working. You're like, everybody remember the story of Thomas Edison figuring out the element in the light bulb? Like he tried thousands of things before he figured out the way to do it. Now, good news is it shouldn't take us thousands of attempts, but it may take us 1, 2, 3, or 4 attempts. Is that making sense? So why did I do that? Well, I noticed that I could factor that yellow highlight. So I tried it, and I got stuck, and it didn't work. So, what's another option? There's a Pythagorean identity. That yellow highlight is a Pythagorean identity. Oh, I need to revise my yellow highlight. That is a Pythagorean identity. That yellow highlight is equal to the Pythagorean identity tangent squared theta plus 1. So, in my attempt 2, I'm going to try using an identity. The yellow highlight becomes the yellow highlight. And in this attempt 2, plus 1 minus 1 cancels out, and I'm now down to tangent squared theta over secant squared theta. Oh, I'm getting somewhere. I'm not there yet. I'm moving my last line down. I know when I'm done. I know that I'm done when I get sine squared theta equals sine squared theta. All right. I'm going to use the strategy, get everything to sines and cosines. So tangent squared is sine squared theta over cosine squared theta. And secant squared is 1 over secant squared is 1 over cosine squared theta. So I used trig identities. And I highlighted. I kept it color-coded. Pink became pink and orange became orange. Does everybody understand the substitutions that I just made? All right, I know I'm done when I get sine squared theta. Oh, yes. The whole time I've been doing this, on the right side, I have not messed with equals sine squared theta. equals sine squared theta equals sine squared theta. That I have not touched the right side. I am just manipulating the left side. All right. On the left side, sine squared theta over cosine squared theta. If I'm dividing by 1 over cosine squared theta, it's the same thing as multiplying cosine squared theta over 1. Division of a fraction is same thing as multiplying by the reciprocal. Oh, this is awesome. I can now show you and explain that cosine squared is a common factor that factors out of the denominator and numerator, and I'm left with sine squared theta over 1 equals sine squared theta. And the last time I checked, sine squared theta divided by 1 is sine squared theta. Check. I'm done. I have shown the entire process, step by step, how to manipulate secant squared theta minus 1 over secant squared theta and manipulate it step by step and show you how it simplifies down to sine squared theta. This is our first complete example of verifying a trig identity. And we are now done example 1 because we have proven that sine squared theta minus 1, I said that wrong, that secant squared theta minus 1 over secant squared theta is equal to sine squared theta. We have shown it because we have proven how to manipulate secant squared theta minus 1 over secant squared theta and manipulate it down to substitute, solve, simplify, and get it down to sine squared theta equals sine squared theta. I'm going to pause this video or stop this video.